Very good morning, friends. Today we are going to take a different variety of problem on the printing and binding problem that we have done the other day. So that was a straightforward problem that we did. And today we're going to slightly have a variation of this problem. Okay. So let us start with the problem. And the matrix was given like this. It was the matrix was and I had here 5 machines. I had 5 machines, so I will have this. I have 5 machines, and I've got 5 jobs and 2 machines. So the jobs are 1, 2, 3, 4, 5, and 6. Okay, and I have got machine A and B. They'll put a dash here, that is job 6 has not yet come in for process. This is a variety of problem that I am talking to you, which we have done yesterday. These are the machining times that has been given. It is 40, 50, 90, 60, 80, 30, 60, 30, 50, and 40. Okay, so A is nothing but it is printing machine, and B is nothing but it is a binding machine. You may get the problem like this. Simply, they would have put job number, these are the jobs, and there's the machines. Simply, they would have put job number 6 here, okay, and given dash and dash. So this will create a lot of problem for you. Why they've given dash? There are 6 jobs. Dash means that job has not come in yet. Okay, so it is as good as this job is not there. Okay, as good as this particular job is not there. So you do not worry about this. Okay, just to see your common sense, how you approach the problem. Right now, you have to put a sequence for this job and find out the total processing time. And this you have done yesterday. You have found out the best sequence and you have done a processing time. You found out the processing time, idle time for machine printing, and idle time for machine binding. Now in this problem, they are likely to slightly twist it, okay, and they are likely to say find the optimal sequence which you have done yesterday. Find the optimal sequence, but this is what they put, but there is a constraint, but there is a constraint. There is a constraint. So what is the constraint? Constraint is you must process job 2. You must process job 2 in the beginning itself. In the beginning itself. Okay. Now, this is the constraint that they have given you. Generally, what we do, we'll find out the best optimal sequence and we'll solve the problem. Now here he has already told you that job 2 has to go in first. So job 2 को तो पहले भेजना ही है, वो sequence में आएगा ही नहीं. Now you will start getting confused. अरे बाप रे, अभी how to solve this problem? Very easy. Okay, we'll write the solution. You know how the sequence is. We have got 5 jobs. 6th one is not there. Simply they are going to confuse you. So I'll have 5 blocks here. Okay, which job will go first, which job will go second, I have to write here. Now I require to do the sequence. I require to do the sequence. Am I audible and is the board seen? Just reconfirming.
Yes,
Yes,
sir.
sir.
Okay. Okay. Right. Now, again, I'll keep repeating. 6 jobs I'm giving you for confusion, putting it dash, so it is as good as 6 job is not there. So we have got only 5 jobs and 2 machines. Now here what he has given that job 2 has to be processed in the beginning itself. Okay, this is what he has given. Now we require to do as they have said. So job 2 means I have to write first job 2 here. Why? Because he has already told me, he has put a constraint saying that job 2 has to be processed first. I cannot do anything. Okay, so that means job 2 is already processed first. You remove this from here. Now what happens? My problem gets converted into 4 jobs and 2 machines. Am I right? It'll get converted to 4 jobs and 2 machines. Job number 1, 3, 4, and 5. So it is 1, 2, 3, and 4. So my problem gets converted to a 4 jobs problem. Right? Now I will start using the algorithm and solve this problem. So what is the algorithm? The algorithm says I will take a green ink here because job 2 I've already put in the first, so it will be easily understandable. If minimum corresponds to first machine, process it first of all. If minimum corresponds to second machine, process it last of all. Which is the minimum now in this remaining matrix?
30.
It is 30. 30. Okay, we'll take any 130. You can take anything. We'll take this 30. Okay, so which is this job? Job 3. It is corresponding to second machine. So this minimum is corresponding to second machine. I have to process it last of all. Which job I'll process last of all? Job number 3. So this is gone. Next minimum I have to find out. Next minimum is again 30 here. It is corresponding to the second machine. So I have to process job number 4 last of all because it is corresponding to second machine. So last of all means I will process it here. So this job and timing is also gone. The next minimum is how much?
40.
40. Take any 40. Either you take this or you take this. Take any 40. Let us take for a change the first one. We'll take this 40. This 40 is minimum corresponding to the first machine. So I have to process that job. First of all, what is that job? That job is this job. And hence I will process it first of all. First of all means I'll go from left to right. So this is known as first. Because this I have already, this part I have already entered. Nah? Because there's a constraint. They had already told me that first job has to be 2. So I cannot do anything here. Okay. Now I have entered 1 here. What is remaining? So 1, 2, 3, 4. So 5 is remaining. I will enter 5 here. I have got my sequence. Okay. Now with this sequence, I will find out what is the total processing time, total idle time, and let us compare it with the solution that we have got yesterday, where there was no constraint. They did not tell me to put job 2 in the beginning. Okay. So now there's something, there's क्या बोलते हैं वो जबरदस्ती उन्होंने बोला है कि job 2 ಎರಡನೇ ಜಾಬ್ ನ ಮೊದಲ ಮಾಡಬೇಕಂತ ಅವ್ರು ಕನ್ಸೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಕನ್ಸೆಂಟ್ दिलेला है. ठीक है, कोई बात नहीं. मैंने तो अभी इसको लिख दिया यहाँ पे 2 I have written here. So the other 4 sequences I have got. Let me now find out what is the total processing time. Okay, so let me draw the so I got one answer. Now I'll go for solution number 2. Okay, so I will say these are okay. I'll say this is machine A, this is machine A, this is machine B, and 2 is already there. I cannot help it, and I write the sequence 1, 5, 4, and 3. So you have to be very careful that this sequence is written here. Now let me start with the solution. 2, I put it in and out, in and out. 2 enters machine A at 0th minute. 2 requires how much time on machine A? 2 requires 90 hours on machine A. So it will come out at 90. It will enter B at 90. Job 2 requires how much time on B? It requires 60. See, a B requires 60. So it will become 150. 150. करेक्ट ना? तो यहाँ पे 60 ऐड हो जाएगा और यहाँ पे 90 ऐड हो जाएगा. So job 1 will enter now at 90. How much time does job 1 require on machine A? Job 1 requires 40 on machine A. So I will 40 on machine A. So the job 1 comes out at 130. But it cannot enter at 130 here because machine B is busy up to 150, correct? So earliest it can enter, earliest job 1 can enter machine B is only at 150. I'll just indicate here slightly so that it will be understood. This is 150. Now it requires how much time? 150 on machine B. Job 1 requires on machine B. Job 1 on machine B requires 50.
50.
So I'll add 50 here. What time will come out? It'll come out at
200.
200. So job 5 will enter at 130. How much time does job 5 require on machine A?
50.
50.
Here it is 50. Okay, job 5 on machine A is 50. So I will add 50 here. So after 180 minutes, job 5 will come out from machine A. What time can job 5 enter machine B?
200.
Very right, because now the job is waiting because the machine is busy here. Okay, hence the job is waiting. It will wait up to 200. Okay, so this will come here now. Okay, 200 will come here. Then job 5 enters machine B at the 200th hour. How much time does it require? Job 5 on machine B
40.
40.
on machine B requires 40. So I will add 40 here. It will come out of machine B at
240.
240. So here it will enter, job 4 will enter at 180. Job 4 requires how much time on machine A? Job 4
60.
requires 60 on machine A. So what time will come out?
240.
240. See here, so wonderful. Okay, 240. This also finishes at 240, and this also finishes at 240. So at 240, correct, it can enter. Job 4 can enter machine B. How much time does job 4 require on machine?
30.
Job 4 on machine B, 30, correct? So
30.
yeah, 240. So after 30 minutes, 30 hours of processing, it'll come out at 270.
270.
Yeah. So job 3 will enter at 240. How much time does job 3 require on machine 1? 80. Correct? So 240 plus 80 is
320.
320. Good that you are all alert. Very nice. When will job 3 enter machine B?
320.
320.
Correct. 270 B is free, but it cannot be consumed because 3 is still getting processed. So it will enter at 320. So for your benefit, I will just mark it here. It is this 320. Okay. Now job 3 requires how much time on machine B?
30.
Job 3 require 30 minutes on machine B. So if I put 30 here, I'm going to complete all the job at
350.
350. Okay. So what is the total processing time?
350.
Total processing time is 350 hours. Idle time for machine A is equal to how much?
350 minus 320.
350 minus 320. That is
320.
yes. Okay.
30
Where
minutes.
is it is this is 350 here minus 320. So 350 minus 320, it is 30 hours.
30.
Okay. How much idle time is there For B machine,
90.
okay, so initially see here 90 is there here, okay, here 90 is there. You can see the pen cursor, what I'm showing,
Yes,
visible?
sir.
Yeah, okay. Okay, so 90 is here. So initially it is 90, then 90 to 150, 150 to 200, 200 to 240, 240 to 270, 270 to 320. Here there is idle, correct? Here it is idle. So plus 320 minus 270. Okay, here idle time is there. And 320 to 350. So 320 minus
270.
270 is how much?
50.
50. 50 plus 90,
140.
140 hours. Friends, such problems, if they come, it will be almost for 15 marks. Okay, you should be very careful when you're solving such problems. The possible mistake that you will do, I've told you yesterday, okay, that you will go wrong only in, okay, putting this sequence. That sequence is easy, putting this sequence here, okay, don't go wrong there. Next is, whenever you do some allocation, whenever you do the allocation, you strike it off, because in the examination tension, if you don't strike it off, then you may put that job again somewhere here. So you may have 2 here and again 2 here somewhere, or 1 here and again 1 here somewhere. So once the job is completed, you just strike it off with a pencil. Okay, so you are sure that you will not put that job again, because in the examination you can tend to make this small errors. Okay, so this is got to do with some variety of problem where in sequencing they can give you simply 6 jobs and give you dash. That means 6 jobs has not come only. So this problem gets converted to 2 machines and 5 jobs. Okay, now in that again a little variety is that they may tell you a particular job should be processed in a particular sequence. In this problem, they have said that job number 2 should be processed first. It has to be processed first. So ye jabardasti hai, doesn't matter. I'll write 2. Now I have to do the sequencing only for the other 4. So my problem gets converted to 4 jobs and 2 machines problem. And this is the solution that I get. Yesterday, the problem where there was no constraint and I found out the solution. What was the answer? What was the total processing time?
350 only, sir.
350 only. And idle time?
Yes. Idle time also same, sir.
Idle time also same. That means there is no difference in the solution if I process job number 2 in the beginning. Okay. Now in the examination, if they give you a problem for 20 marks, they are likely to say compare both the solutions. Okay, compare the solution when the sequence is given, when you find out the normal sequence, and compare the solution when there is a constraint. Okay, now please you solve the same problem. You solve the same problem with the constraint. Okay, solve the same problem with the constraint. Please write down the problem. Please write down the problem. Solve this above problem of 5 jobs and 2 machines. 5 jobs and 2 machines. But the constraint is that job 2 has to be processed last of all. Job 2 has to be processed last of all. Okay, so a very nice and classical problem you have here. When you get a sequence, he has given you a constraint that job 2 should be processed last of all. So how your solution will be, you will already write 2 here. Earlier what it was, job 2 to be processed first of all, that was the constraint. Now they have given job 2 to be processed last of all. So do this problem and find out what is the difference between this problem, the total processing time of this problem, and the total processing time of the problem that you're going to do now, where he has said that job 2 should be processed last of all. Okay? So with this, we end the 5 machines problem.